awkward. Lo siento. Where's my remote? Here we go. Okay. So yesterday, learning how to put pieces together with trig. One of those legal moves is factoring. One of those legal moves is simplifying, which means looking back to the big old table or rearrangements of the table to plug in. It was a little confusing because you don't see what you're supposed to be getting every time. So this one was our quick example of where do we stop, where do we stop, where do we, oh, that's a natural stopping place. Okay, we're learning when to stop. I've given you a little bit of hope that in section 5.2 you'll be given the picture to the puzzle so you'll know where to head, which can be good and bad all at the same time, and you'll learn that as we go. But 5.1, we're just learning how to follow the directions, aka how can or what can we do to trig expressions. We can factor, oh, a GCF. We can factor, oh, a difference of squares, and that helps. We can factor, oh, it's a trinomial. But we have to do some more like, oh, we can get, well, this one's kind of awkward. It just says simplify. But we're going to see in a second, oh, we can get common denominators. That can help. Oh, we can substitute and simplify. That can help. We're learning just kind of how the pieces work together or different things we can do, all trying to get to what we saw yesterday is the ultimate goal of getting these equations that are basically impossible to solve unless you change them. In your groups, how far you can go. Go. The directions are super basic. But I did stretch you off yesterday. Joe and I think a couple others were giving me ideas, a quotient property. I'm going to do one more hint, and then I just want to see how far you and your group can go. How far you and your group can go. Tyler's gone today. Just Tyler? I'm going to show what I would do next. Uh-oh, my remote works. If you got there, cool. If you didn't get there, ponder that. What would you do next? Go back to your groups. They should change by the end of the week, just change things up. But for right now, easing back in. We're starting off in our same groups for a little bit longer. She's here. But hopefully you see it. Why'd I do that? Just cosine beta is cosine beta squared, but remember there's a snazzy way of writing it. Bless you, bless you. I'm going to do what section 5.2 would do. I'm going to give you the end of the puzzle. The picture you're supposed to be making match. Kind of like a geometry proof. Can you fill in how to get there? Try to work backwards. Use your table. Who is secant? Who is secant? Who's 1? P.S. Look at the Pythagoreans. Remember that if you have like denominators, you can combine. Or I should say common denominators, you can combine. Pythagoreans. Point to your group, help them out if they don't know how to get there, and you do. Wasn't a bad idea, but I wouldn't change both. If you just changed one, then you would have gotten there too. Changing both confused you. Some of your connections fast. Some of your brains are going to go too deep and actually do too much work, and it's going to kind of lead you down a weird direction. And some of you, the basic math's going to get a little confusing. But can I fill in the pieces now? Common denominator says, oh, no big deal. Put it together. And as you learn your properties, sine squared plus cosine squared is, oh, such a good one. Because it's really just 1. And 1 over cosine is secant. Now the sad thing is, in this section, you're not going to know that's where you were supposed to stop unless you look at the back. That's okay. That's like looking at the picture of the puzzle and saying, where did they go? What if it's an even? Go as far as you can, stop, and we'll grade it tomorrow. There's no shame in not getting far enough. There's no shame in going too far. If you don't know when you're supposed to stop, it gets confusing. So you're learning that. Part of working through this section is learning when to stop. But they said to simplify, so you had to be able to do something. So there are sines, there are cosines. Maybe the quotient property was a good idea. Reciprocal property of tangent, 1 over cotangent of beta. But there are sines and cosines, so use the quotient property. Then go ahead and do some math of multiplying, and then realizing, well, I can't do anything unless I get a common denominator. Still just kind of using math techniques with fractions. Putting them together, and then go looking at the identity. So some of it's just math, and some of it is identities, and you'll have a little bit of both in some problems. But what was the farthest you could go, should go? Probably here, of secant of beta. So when they tell us specifically get common denominators, do you understand why they're saying that? I have 2 fractions. What do you do? We saw in the last problem with 2 fractions, maybe it's nice if you get a common denominator. And the nice thing is the directions totally tell us to do that here. So this one, the denominators might be a little bit more complicated. It's not just cosine like this one was. But that's okay. We can still do the math of getting common denominators by saying, well, they're not the same. So what do we do with 2 fractions that are not the same when we need a common denominator? We make them the same by, well, what if you had 1/2 plus 1/3? Can you combine those 2 right now? Well, yes, but not until you at least what 1/2 is in terms of 6, right? Or what 1/3 of is in terms of 6. Them by themselves. If the 2 denominators sort of common factor, because I'm silly, we would multiply the 2 by the 3 top and bottom and the 3 by the 2 top and bottom. Just math, so what are we going to do? But we don't have 2's and 3's. What do we have now? Secant x plus 1. Careful. We have little binomials. We got to keep them grouped if we start multiplying, or else we'll make some huge distribution seal errors. We have secant x plus 1 that we need over there, and then over here we must need I don't want to steal all the fun, so let's see how far you can go on this one. And I'll show you the picture. I'll show you the final answer in just a second and give you a little more time to see if you can make it match. But let's see how far you can go without seeing the answer yet. Multiply with the purpose of combining, with the purpose of simplifying. go ahead and collaborate as you also ponder the final answer. Talk in your groups. Some people were able to go somewhere, but it's not matching. Some people were gonna try something, not sure if it's right. Some of you might want to try to go backwards. It might be a little hard. I'll give you a little bit of time to see if you can fill in the missing steps. Okay, pause. I see way too many people stuck in their own work and just kind of staring at it. Pause. Talk, compare. Maybe someone has an idea that you didn't try. Maybe you have an idea they didn't try. Put your heads together. Compare the work. If nothing else, just turn with your notebook if it's too awkward to say words and just be like, here. Some of you might have hope that you weren't that far off as you thought. Maybe. Don't kill a seal. Did anybody get the -2 at least? The secants end up canceling, right? A -1 minus 1 is -2. The secants end up canceling, secant x minus secant x, and then I have a -1 minus 1. That's -2. Well, I'm assuming they don't want me to leave it like that. Sure doesn't look like that. So what can we do? Well, maybe not identity, maybe just math. What can we do if we have two binomials next to each other? Multiply. Oh, yeah. And it's a difference of squares. Isn't it? Yeah. But just in case the difference of squares doesn't make sense to you, it's going to be secant squared minus secant, or I guess plus secant minus secant. Realizing it was a difference of secant squared x minus 1 isn't cotangent squared. X. Wait, look at the rearrangements. Wasn't secant squared of x minus 1, isn't that just a rearrangement of a Pythagorean? What does that equal? Yeah, and that's in the denominator. Who's 1 over tangent? Tangent squared. Dun, 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 dun. Oh, when I got my common denominators, I was able to put them together. And secant x minus 1 minus secant x plus 1. The secant x is canceled, but a -1 minus 1 is a -2. And so I could actually, if it helps, rewrite this to be -2 times. See it? So I could technically pull that -2 or make it -2 times 1 and then see that that's the cotangent squared and that's the -2. Which makes it legal. Yeah. Well, theoretically you could. The question is, if you went to, now that's an even. So a lot of you, if you could have like done a lot of work, you would have ended here-ish and then maybe stopped. So when we checked it in class and the answer was that, would it make sense? Does that make sense? Yeah, would it make sense? And don't worry, remember, section 5.2 is coming where they're going to say, okay, well, you've been trying to work with the pieces and figure out what's legal and what's not legal and figuring out how something can change to be something totally different. Section 5.2 will always give you this piece. So then you're like, oh, I have to get there? Okay. Which will make it a little bit easier in some ways, because then you have to get, like, you know where you're going. But it'll make it a little bit harder, too, if you can't get there. Or if you get stuck on the way. But yeah, for right now, for section 5.1, you're just trying to be like, oh, I think this makes sense. I'm going to try it. And then the odds, go to the back and say, okay, can I make mine match? And the evens, be like, well, I think I'm right. And then come in tomorrow. Any questions before I change this one, though? Lauren, did you get it okay? What's this guy? We're just following directions in this whole section, being like, all right, I'll try that. Okay, I'll try that. All right, I'll try. So go ahead and write it down. We're going to, all right, we'll try. Oh, substitute, though. We've been using that word for forever, right? Plug it in, plug and chug. Oh, good question. 46. Yeah, 46. But let's just do it all together, because we haven't really seen this direction yet. Substitute. Oh, well, what'd they give us? Yeah. P.S. If I were you guys, I would maybe highlight this example in your notes. Not because you're going to use it over and over and over and over and over again all chapter long, but when it shows up on a quiz or a test, it's one of the most commonly missed ones. Because of how kids plug it in or mistakes they make along the way. It's actually not hard. So a lot of people just kind of breeze over it and say, oh yeah, I got that. I would never make a mistake on it. And then I take off points all the time if it shows up on a quiz or a test. So just highlight it that it's tricky. Isn't plugging in an easy concept though? Right? Like plug it in. You guys tell me. 9 minus what? Good. Think function notation. The whole thing has to go into the x. So what needs to be squared? So 3 cosine theta times 3 cosine theta is 9. Now if you were, careful, simplify. If you were to go to your table of identities, or even the rearrangements, is there any identity that has the number 9 in it? No, the same way there wasn't one that had the negative 2 in it, but we kind of thought about it off to the side. What can we do with 9 to get it away from what's going on? Pull it out. But we can't pull it out of the square root yet. But we can factor it, right? Couldn't we pull out the 9 and get 1 minus cosine squared? This allows us to see what's going on besides the 9. So what's going on besides the 9 is 1 minus cosine. Now compare. Way too many people either forget to square the 3, totally don't realize they should factor, or totally start killing by rooting across addition fractions. When there's a very, very, very legal way of saying, oh, 1 minus cosine squared is, Joe, louder. Sine. Sine squared. Good. And if I can get rid of that subtraction using an identity, all of a sudden it's totally legal to square root. It wasn't here. It wasn't there. It's not here. I'm not legal. It wouldn't be legal to distribute a square root. The square roots aren't multiplication. Don't kill puppies. But, ha-ha, I can square root this. 9 would have come from 3 times 3, and sine squared would have come from Sign. If you want to be super, super, super snazzy, technically the square root of anything squared is always absolute value. If you correct. Technically, only positives come out of square roots of squares. Only positives come out, which is a little bit confusing because when you take away the squared, he could be positive or negative, but it's not actually legal for him to be negative, which is why the absolute value is going to show up in the answer. It might just throw a few of you off because this little fact from Algebra 1, a lot of kids don't remember. It just wasn't hammered in well enough. Is this crazy hard? Not when I do it with you. But if you do it on a test, do you see how many little mistakes you could make? Maybe it's this one, maybe it's, 3 minus 3 cosine. No, so wrong. But if you just factor and then use a little Pythagorean, it's easy. How are we doing? Tyler, good? Okay. Section 5.1. Let's go see what on earth is going on in 5.2 then. But first, anybody want to ask me anything about 5.1 you got stuck on? You're like, I don't know how I got there. You don't have to. I'm available. Anything from 5.1? Some of you are like, I still need to try it. Totally valid. That's okay. It's not due till tomorrow. P.S. Someone help Tyler out about the whole PDF picture thing, just in case she wants to try it, but you can talk to her later about it. Nothing from 5.1? Does anybody have the problems written down from 5.1 and you want to look really quickly at one that looks hard that we can do together? I don't know. Maybe you have one. It's searching. I'm almost there.
I do.
My computer's going as slow as you guys loading pictures on your Google Classroom. Okay, give me one.
I don't know half the questions. I only got to like...
Are there any... Well, where did you get stuck, Jason? Let's start there. Where did you get stuck?
I kind of ran out of time.
Oh, okay. Anything that you got stuck on or like not completed in the ones that you tried?
No.
Okay.
You can just add the numbers if you want to pick one.
What do you guys think? Like around here-ish, does that look nasty?
Oh, 29 is kind of gross.
29 is kind of gross. It's a factoring one. Do you guys want to do a factoring one?
Yeah,
20? 20 is a little nasty unless you use a cofunction property. 20 is or isn't? Oh, 20 is not. All right, let's peek at 29. That one's not a bad one because it is a trinomial. But I don't mind doing one more. I think we can do one more. Let me draw your attention to a certain section. I would say something in this range. Pick one from homework, those of you guys that have homework written down. Somewhere between 35 and 48. 45. Oh, that's a lot like class. Are you sure?
Oh, 36. Really 55? Just because it's like the last one?
I think 55 is one of those pluggy-in ones.
Oh.
So I don't think he'll be bad.
So 37, that's the only other one.
37?
Yeah, that's in the range.
That looks nice. All right. I'm going to go pretty fast. And I might not finish it, but I'll at least get you part way there. P.S. Most of you haven't done homework, so if I were you, I'd be in the back of your homework spiral or in your notes because these are actual homework problems. Okay. This one. What do you guys think the directions are, even though I didn't copy and paste it? Yeah, but what's the word going to be? What are they telling you to do with this? Maybe. Actually, this one's simplify, to be honest. This one, simplify, makes sense. This one, they're going to tell you something very specific. Joe's right. It's an ax squared plus bx plus c kind of form. Yeah, they're going to say factor. Is there a GCF?
No.
Is it a difference of squares? It's a trinomial with a number in front. What factors? I'm going to go ahead and do grouping just because yesterday I tried to do the other method. I'll show you where the other method could have been used, but for right now, grouping. this little guy is going to become negative 6 sine plus 1 sine. This would be the good old-fashioned grouping method. Splitting this guy up, using each of these. What's in common? Do you guys see a 3 sine of x? I do. Now remember, that's a sine squared of x, so if I take away 1, there's still 1 remaining. And? We could put a little understood 1 in there. So then we end up with 3 sine x plus 1 times sine of x minus 2. And actually, some of you were thinking simplifying, and the reason I wanted you to know the directions just said factor, because there's not really much to do. You could FOIL and get back there, but didn't really like that. They wanted me to factor. So just stop. When they say just factor, follow the directions. They're just teaching you or having you practice skills with trig expressions that might come in handy somewhere else. If you guys want to see the crazy modified x method, the problem yesterday is I put the line on the bottom instead of on the top. You put the line on the top, and then you put your 3, and then put your 3, and then simplified. Do you see it? 1 sine of x plus 2 and 3 sine of x. Sorry, 1 sine of x, that's a minus 2. That's my bad. There's a negative there. 1 sine of x minus 2 and 3 sine of x plus 1. But that's a trick to expanding the x method if you want to try to be learning that. Joe? If the same... If this was 3 and 6, and this was 9 and 3, and you took out 3 from both, then there would be a GCF that you didn't see to begin with. Does that make sense? If you do all of them, GCF that should hold out to begin with. And so the directions of this method, the x method, a little bit harder. Because when you factor, it doesn't consider the GCF. Does that make sense? Cool. Number 37, just simplify. What would you guys think of doing? Distribute? Yeah, sure. That's math, right? We can multiply.
What letter is that?
Phi, phi, fo, fum. Phi. Phi. I never know how to say it, so I just say both. And I quote. Is it phi? It might be phi. I guess phi and pi makes sense. If it's pi, it'd be phi. Phi kappa. Oh, yeah. You're right. You're right. Phi, phi, fo. Gulliver's Travels. That's where it's from. No. Phi, phi, fo, fum. I smell the blood of an Englishman. Isn't that like Jack and the Beanstalk? Isn't it the giant from Jack and the Beanstalk? Or no? When he like gets up and then like, Phi, phi. Anyway, now what? We're done? No. We just multiplied. Any other ideas? Cosecant is 1 over sine? Oh my goodness. It's like you guys are getting the hang of it or something. Too much help. Okay, yeah, you guys got it. All right, let's go ahead to section 5.2. All right. People started talking about, that simplifies to b. Finish it, but it's an odd, so you can look in the back and it should be able to match. If it was an even, then I might be a little bit more helpful. All right, section 5.2. Oh, nasty. There's words. Don't worry, the homework has barely any words. Back in our notes, new section, new side, 5.2. Huh? I'm going to highlight the most important words. But for right now, before we get to the nastiness down below, this is like straight out of the book the way they put it, and I'll try to simplify. So I'll highlight the important words. This is definitely nothing memorize. It's just, when you get to 5-2, you see where you're supposed to go and you have no clue how to get there. This table, this chart is a place to be like, okay, what can I try again? That's what this is. But first of all, before we get here, before we get to verifying trig identities, verifying proving, proofs, don't worry, not quite like geometry, but similar in process. We need to even talk about who this is. What are identities? Because the struggle is conditional equations and identities are very, very different, but they both have an equal sign. So it gets confusing. Just looking at the English, like the vocab, what do you guys think is the difference between conditional equation versus identity? That is a difference, right? But think about the meaning of the words. But both of them have equals. We could actually call them both equations. Come on, my grammarians or my vocab people. English, conditional. Lauren, hang in there. Conditional. Conditional. Yeah. Okay, so it depends on something. There are conditions to it. If something is conditional, if you're like given a job someday, but they give it to you conditionally, what does that mean? Oh, you're solid, you're good. Yeah, there's guidelines. If you don't meet them, you're probably out of there, right? Conditional equation. I want you guys to think sometimes true. Conditional equation. I want you to think sometimes. Sometimes true. It's true based on condition. And let me give you an example of that. If I was to give you something like 1 minus 2 sine theta is equal to 0. Is that always true? Depends on the theta. If I subtract negative 2 sine of theta equals 1/2, isn't that only sometimes true? Can't sine hit everybody between 1 and -1, like over and over and over and over and over? It's only going to go through half sometimes. This is one that we would rearrange and we would move around and we would say, oh, sine of theta equals 1/2 only sometimes. At pi over 6 and 5 pi over 6, and we can keep on going to find more answers, but that's only sometimes true. It's an equation that's sometimes true and sometimes false. Identity, though. Tangent of theta over sine of theta is equal to secant of theta. Always true. Really? It's not in my table. And it's not going to be. I don't want you to memorize it. But I want you to be able to show me that it's always true. I want you to verify that something you've been given is always true. But how could you verify that this guy is always true? If he's not in the table, he's not like a fact you've had to memorize, how do you know he's true? Oh. We could start playing with this guy and see if he matches that guy? So then Joe's saying make tangent sine of theta over cosine theta. Dividing by sine is the same thing as multiplying by the reciprocal. I know I'm doing the math fast. I don't have a lot of space. What happens to your sines? And who's 1 over cosine? Is that true? How much of the time? All the time. Oh, so even if it's tangent of 30 degrees over sine of 30 degrees, it's secant of 30 degrees? Yeah. How about 45? How about 57? How about 239? Tangent of an angle over sine of the same angle will always be secant of the angle. Oh. There's definitely life lessons in this. You're not going to always know exactly what to do. Sometimes you have to go back to fundamentals, fundamental principles of worldview, what your foundation of truth is, and then make decisions based on that. But for right now, we're just going to say sometimes true, but always true. We won't always know it because we won't or haven't necessarily memorized it, or it's not in your table. So how can you show me it works? Well, show the steps. And by showing the steps, you're training your brain as to how these transformations can happen so that when we get to section 5.3 and 5.4 and 5.5, and you're given these equations that are impossible, you're like, oh, but I can change this, and I can change it to be that, and I can make that into this, and then I can solve it. So 5.2, you're just going to be verifying true statements. They're all true. No geometry trick ones that are impossible or false. Okay? No, like, not a possible triangle. Nope, nope, nope. All the statements you're given in 5.2 is one side, hey, this equals that. You're going to be given what the end is supposed to look like. You're going to be given the picture or the equality statement, and you have to take one side and make it match the other. Now, hold on, wait. Didn't I just say a second ago another word for verifying is proving? I want you guys to stand up really quickly, and in your groups, I want you to tell each other anything you can remember from geometry proofs, 2-column proofs. Go. Some people need to wake up. Turn in your groups. Anything you remember from geometry and 2-column proofs. It could be something that you wrote down. It could be how you wrote it down, what you were given. Anything from geometry proofs.
Learn how to verify that you make a sandwich with you mess up
To your groups. You're talking, you're discussing. Anything from geometry. Yeah, look at me. Okay, someone tell me something. I heard like ASA and SSS, and there was something that you put in the... Wait, what'd you do with proofs in geometry? How many columns were there? 2. What was always the first thing that you were given in a problem? The given. And what were you supposed to do? Prove. They told you the answer? They told you the beginning and they told you the end, and what were you supposed to do in between? Show the steps and have a reason why you did it, right? Here's the nice thing. In Precalc, you don't have to have a reason why, but you do have to show the steps. We'll get here and summarize it tomorrow. But can I show you an example of one real quick? You can do it with me or you can just watch. I don't care. We're going to go ahead and split this into 2 columns. That's the first step of every problem. Split it into 2 columns. Then we're going to choose a side. And here's the dealio. This could be the given and that could be the proof, or that could be the given and that could be the proof. Equations go either way, so it's up to you. But you're going to show me which one is the given, just like you did in geometry by writing the first one given, by rewriting the side you choose to start with. And your goal is to be able to make this end in the other one. But you have to show me the steps in between about how this can get to that using that big old table of identities and using math. And maybe some of you guys can see some strategy as in, I like him, you stay. I don't like you, you get substituted for something else from my table or my rearrangements. And maybe some of these aren't so bad after all. And you show me that you got from your given to your prove by rewriting over here. And so instead of me making you use words and all that jazz, you're just going to use a notation that we call a T proof, where we split every identity into 2 columns. You choose the given column, whether it's on the left or whether it's on the right. You rewrite it saying, hey, he's my given. You do this. Oh, it's my proof. I got it. Dun, 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 dun. That's the goal. That's what we're going to be working on in 5.2. But before we get to 5.2, what do you got to practice? All the stuff in 5.1. Finish up 5.1 for tomorrow, and we'll see how you guys are doing on the skills, and then we'll go ahead to playing with the puzzles. Bye, guys. Work on those skills tonight. Come tomorrow with questions.